Okay, so we have a nice little formula here for our radius. So if I have n up to n circles if I have n circles at the bottom, how many total circles do I have?
You'll have n times n minus 1 over 2 total.
Alright, let's see. N times n minus 1 over 2. Let's see, so when n equals 1, how many circles should I have?
You should have 1.
Alright.
You have 1 times 0 over 2, so that wouldn't be the right. I think it's n times n plus 1.
Okay, so let's just check for n equals 1. Does that give me 1?
Get 1 times 2 divided by 2, yes.
Alright, for 2?
2 times 3 over 2. So, yep, you do get 3 circles.
Alright, for 3 do I get 6?
Yep. 3 times 4 over 2.
Okay. And then I'm gonna, if this is my radius of the circle, what's my area?
You would multiply, you would square this and multiply it by pi, and then multiply by this, because
so pi over 4, so pi, multiply by pi, square it, that's the 4 on the bottom comes from the 1/2.
Yep.
And then I have this expression, 1 over root 3 plus n minus 1 squared.
Squared. Okay. Well.
Okay, so I can simplify this a little bit. So I get pi over 8. And on the top I have n times n plus 1.
Yep.
And on the bottom I have
Root 3
plus n minus 1 squared.
Okay.
And so as n gets large, the interesting question is, what happens to this expression?
Well, this plus 1 won't really matter, so it'll look like 2n on the top, or n squared.
Okay. Yeah, so as n gets large, sorry, I'm erasing all sorts of things here. As n gets large, this starts to look like pi over 8 times n squared on the top. And what about the bottom?
Well, the root 3 won't really matter, and this will just become n squared.
Yeah.
Yeah.
N squared?
So that'll just become 1.
Yeah.
It looks like this will become pi over 8 as n gets very large.
Yeah, so as n gets very large, we're going to pi over 8. And so we already had said the area of the circle was root 3 over 4.
Root 3 over 4. See if that's any close to...
What do you think? Do you think does root 3 over 4 equal pi over 8?
No, it doesn't.
Okay, how do you know?
Because, well, pi is irrational, and...
Well, root 3 is irrational.
I mean... But that would mean, if you would cross multiply, you would get 8 root 3 equals 4 pi.
Uh-huh.
So 2 root 3 equals pi.
Yeah.
Which is not true.
That doesn't seem to be true. Okay, well, let's just check. One side, sorry about that. One side is 3.14159.265 divided by 8, so that's about 0.3927.
Yep.
And remember, you said at least this ought to be smaller than that.
Yes.
Alright, so root 3 I don't know off the top of my head, but I think I can turn the calculator sideways. Is that square root? Yeah, okay. So 1.732 divided by 4 is 0.4330.
Alright, yep, so root 3 over 4 is a little bit bigger.
Yeah, and so are you surprised that you don't get the whole area? Oh, geez, are you surprised that I was writing off screen the whole time there? There we go.
Well, I mean, you shouldn't get the whole area with a finite number of circles, because you always have these small gaps in between, but
Uh-huh.
with infinitely many circles, the gaps should be infinitely small. So yeah, I am a little surprised.
Yeah, this is a surprising result. The problem is the circles are infinitely small too.
Yeah.
So the size of the gaps and the size of the circles are comparable to each other. So it's hard to actually know for sure, but it turns out that if you try to pack circles into a triangle like this, in this specific way, you're always going to have gaps.
All right.
So that's interesting. You almost fill up the triangle.
Yeah,
You
but
don't-
not quite.
But not quite. All right, good work today, huh?